Number 1, a car averages 17 miles per gallon. If gas costs $3.49 per gallon, which of the following is closest to how much the gas would cost for this car to travel 1,717 miles? Well, you first need to figure out how many gallons of gas you're going to use. Figure that out. You take 1717, the total miles, and divide it by how many miles you can get on 1 gallon. So if you take 1717 and divide by 17, that gives you 101. This is how many gallons this person's going to use. To figure out what that's going to cost then, take how many gallons you have, 101, times the cost per gallon, which is $3.49. That's going to give you the total cost of this trip. That comes out to be $352.49. Number 2, when x is 2 and y is 4, by how much does this value exceed this value? Well, to figure this out, you need to take the first one, substitute the numbers in for x and y, take the second one, substitute the numbers in for x and y, use your calculator to figure out what those are. It gives us 4 for this first one, -4 for the second one. Then the question is, by how much does the first one exceed the value of the second one? So how much more is 4 than -4? So to find that, you take the 4 and you subtract from it the -4. That's going to give you +8. It exceeds it by 8. What is the value of x? This is telling you to solve the equation. If you were to subtract 4x from both sides, you would get 3 equals x minus 8. And if you add 8 to both sides, you get x is 11. The value of x is 11. Greatest common factor. If you make a factor tree of each of these numbers, you break it into prime numbers. 21 breaks down to 3 times 7. Those are prime. 63 breaks down to 3 times 21. 21 breaks down to 3 times 7. 105 breaks down to 3, and 35 breaks down to 5 times 7. Figure out the greatest common factor. You compare these, and you circle numbers that are in common. This has a 3, this has a 3, this has a 3. This has a 7, this has a 7, this has a 7. The greatest common factor, you take all the factors that they have in common, 3 times 7, you multiply them, and you get 21. Greatest common factor is 21. Number 5, sales for a business were $3 million more the second year than the first. Sales of the third year were double the sales of the second. If sales of the third year were $76 million, what were the sales in millions of dollars for the first year? Well, let's try to figure this out. First year, I'm going to say that's X. It says sales were $3 million more the second year than the first. So whatever the first one is, which is X, the second one is $3 million more than that. So I'm going to write 3, and this is in millions, and this is also in millions. And then the sales for the third year, were double the sales of the second. So if you take the second and double it, that means times 2, you get the sales for the third. Then it tells us again about the third. Third year was 76 million. These are all in millions. What were the sales in millions of dollars for the first year? So we're trying to figure out what X is. Each of these things in the third year are referring to the same thing, so you can set them equal to each other. 2 times the sum of x and 3 equals 76. If you distribute the 2 here, you get 2x plus 6. If you subtract 6 from both sides, you get 2x is 70. If you divide both sides by x, you get 35. Since x was defined as the first year, and that's the question, what were the sales for the first year? It's $35 million. 6. In the figure below, array EF, that's this array right here, was constructed starting from arrays ED and EG. So the black arrays were there, and then using construction, compass and straightedge, they found the red ray. It says D and G were marked equidistant from E on rays E and D and ray EG. The compass was then used to locate point F, distinct from E, so that F is equidistant from D and G. For all constructions defined by the above step, the measures of segment DE and segment GEF, and then you're supposed to figure out how are those related. How is DEF related to GEF? Well, the answer is they're congruent to each other. This process that is up here is the description of how to find the angle bisector of an angle. And there's no easy way for me to explain that. That's just the process that you do to find an angle bisector. You would find that in your geometry class. Abandoned mines frequently fill with water. Before an abandoned mine can be reopened, the water must be pumped out. The size of the pump required depends on the depth of the mine. If the pumping out of a mine that is d feet deep, d is the feet deep, that's really important, requires a pump that pumps a minimum of this many gallons per minute. Pumping out a mine that is 50 feet deep will require a pump that pumps out a minimum of how many gallons per minute. Notice it says it's 50 feet deep. D is 50 is what this is saying. So you just take and you substitute into this formula for your D's with 50. This is going to tell you the gallons per minute. Put that in your calculator. That ends up being 150 gallons per minute. The length in inches of a box. Say we got length and width. The length in inches of a box is 5 inches less than its width in inches. So let's say W is the width. So what is the length? It says that the length is 5 inches less than twice the width. So if we double the width and then subtract 5 from it, twice means times 2, 5 inches less means subtract 5. Which of the following gives the length L in inches in terms of the width? That's this right here. Twice the width less 5. In quadrilateral PQRS, sides PS and QR are parallel for what value of x? Well, for these to be parallel, this is a symbol for parallel, and that makes this the transversal. These two angles here are consecutive interior angles. Consecutive interior angles, according to the converse to the consecutive interior angle theorem from geometry, those two angles have to be supplementary, which means when you add their measures you get 180. Therefore x is 130 degrees. Number 10, how many irrational numbers are there between 1 and 3? An irrational number is a number that cannot be written as a fraction using integers. So basically what this question is asking, how many numbers are there between 1 and 3 that are not rational? I don't know. Sorry to say I don't know. I mean, I do know, but it's difficult to describe a rational number. Let's discuss irrational for a second. A rational number, the root of this is ratio, is a number that you can write as a fraction using integers. So like 1/3 is rational. Irrational is something like square root of 3. The point is there's an uncountable number of irrational numbers between any pair of numbers. So the answer to this question is there's an infinite number of numbers between 1 and 3 that are irrational. There's also an infinite number that are rational. If the question had asked something like how many integers, then that answer would be 1. There's only one integer between 1 and 3. That integer is 2. So this is infinity for this question. How many rational numbers between 1 and 3? Infinity. 11. A typical high school student consumes 87.7 pounds of sugar per year. As part of a nutrition plan, each member of the track team plans to lower the sugar he or she consumes by 80%. If you're lowering it by 80%, that means that you're going to still consume 80%. 80% as a decimal is 0.80. Yada, yada, yada. Assuming each track member had consumed sugar at the level of a typical high school student and will adhere to this plan for the next coming year, what is the maximum number of pounds of sugar to be consumed by each track member? Well, if you're reducing it by 20, it means you're keeping 80. If you multiply 87.5 times 80% using a calculator, that gives you 70. So that is the most number of pounds someone's going to consume in a year if they're reducing it by 20%, 70 pounds. In a standard XY coordinate plane below, 3 of the vertices of a rectangle are shown. Which is the following is the 4th vertex of the rectangle? Well, there's 3 different choices for this. Your rectangle could look like this. If that's the case, your point could be here. Your rectangle could look like this. If it did, your point would be here. But if you notice looking at those blue segments, this does not appear to be a 90-degree angle. This right here does not appear to be 90. So that blue probably not going to work out for you. Another option for this is it could be, let's see, like this. The 4th point up here someplace. That case also, that green rectangle looks like it's not a rectangle at all, it's just a quadrilateral. So let's focus on this red one. Sorry to put so much stuff in this picture. To confirm that this is a 90-degree angle here, if you find the slope of segment AB, the difference in y over the difference in x, you have to go up 3 and to the right 4, so that slope is 3/4. The slope of BC has to be perpendicular to that for this to be a 90-degree angle. So if you count from 1 to 8, here you have to go down 9, and then you have to go to the right 3. That reduces to -3/1. This up here reduces to 1/3. These are negative reciprocals of each other, which means these lines are perpendicular, which means this is a 90-degree angle. So this rectangle is going to work. We just got to find the coordinates of this point down here. If we use slope again, to get from point B to point C, we went down 9 and to the right 3. For this line, for line AD, we'll say, to be parallel to that, we have to go down 9 and to the right 3. If you go to the right 3 of -2, you get +1. If you go down 9 from -2, you're going to get -11. So that point would be 1, negative 11. It's the fourth point of that rectangle.